If you've ever let a browser generate a password for you, that password is pseudo-random. It used a pseudo-random number generator and isn't truly random. For today's exercise, we'll be generating truly random passwords using dice as the true random mechanism. The tools we'll be using is this character set, a d20, a dice with 20 sides, a d6, a normal dice, and a calculator that has the division with remainder operator on it. You can see just above the absolute function. Now, to generate the password, we'll be rolling each of these dice a particular number of times. The math will be explained later, and the one shortcoming. But, first of all, you'll have to get your hands on some D20, which for me was just gifted to me. The assumption we're making is that each of these sides are equally weighted, which is false. This 5 is lighter than this 4, which only has 4 dimples, while this 5 has 5 dimples, making this an unbalanced dice. The other accusation that could be made is that this isn't a truly random d20, as all the consecutive numbers are next to each other. This is called a counter d20, and it really doesn't matter. As long as you're rolling it well enough, it doesn't matter that consecutive numbers are next to each other. Just as it doesn't matter that consecutive letters and digits are next to each other on the character sheet. To generate the password, we'll roll a d6 6 times and a d20 4 times. After rolling the d6 6 times, I get these characters. Now, if I had gotten a 6, I would not have written down 6, but in fact 0. Same thing goes for the d20. If I would roll a 20, I will now write down a 0 instead of 20. In this example, I never rolled a 20 or a 6, but the rule applies to make sure that we don't overflow, as when working in base 6, the characters go from 0 to 5, base 20 goes 0 to 19, and base 10, the base we use to count, goes from 0 to 9. To generate our password in base 10, we'll multiply our base 6 rolls with consecutive powers of 6 and add them up. The same logic will apply to the d20s, as we'll multiply each digit with a power of 20. The only difference being that the d20s will multiply with 6 to the 6. This number, 41,426, is the first part. And this number is the second part, 142,228. After multiplying these, I'll just be using the previous answer and answer. After adding these up, we would get our password in base 10. Now this sucks, because we don't want a password that is only base 10. This set of throws have been designed to generate exactly 5 base 94 digits. It doesn't work out perfectly, and I'll show you what to do when it doesn't, but this is what happens 99% of the time. First, we'll save our number. I'll be saving it in slot A. You can do this by pressing Shift, Store, and then A. And now we're going to be using the division with remainder. We'll see that our first character generated is 70, which, by using our table, equates to a star. After we subtract 70, the number is now again divisible by 94. So we'll divide by 94 and repeat the steps. We get 40 for the next character, so we'll subtract 40, making the number divisible by 94 again, and then again dividing by 94. The next character will be 33, and after repeating the steps 5 times, we get 93. And technically you don't have to do it the last time. The last digit is on the left hand side. As you can see, 84 remainder 93. We don't actually have to do the step a last time. Now these digits equate to a star, as previously mentioned. 40 equates to a uppercase O. 33 is an uppercase H. 93 is the last character, /, and 80 would be open curly bracket. So each time you do this, you have a small chance of running into an overflow. This happens because 20 to the power of 4 times 6 to the power of 6 is actually greater than 94 to the power of 5, which is the number we generated here. This is actually a number. Star OH / open curly brackets is actually a number in base 94. But sometimes we have an overflow. We can see that by taking 20 to the power of 4 times 6 to the 6. This will generate, as you can see by taking it to the log base 94, 5 characters and sometimes more. What happens when sometimes more occurs? Well, this last digit will be more than 93. It could be 94 or 95. If this happens, if this last character is ever 94 or 95, you throw away all the progress and start over. If you don't throw away all the progress and just guess a number for the last character, then you are biasing your previous characters in some manner, as they are technically more likely to be some characters than others. If you want a truly random, truly as unpredictable as possible password, you would have to throw away all the effort you have just done if you see a 94 or 5 on this last step. But now, knowing this step to generate 5 random characters from the standard password character set, you can generate any length of password by just repeatedly adding 5 characters and throwing away what you don't need. For example, if I wanted a 24 character password, I can do this process 5 times and throw away the last digit. Thus, I will have a 24 character password. This character, the backtick, is not a single quote. You can see on your on your calculator, on your keyboard, that is a single quote, and that is a backtick. If you've ever wondered why in your coding IDE your code blocks don't work, I've always wondered why my code blocks don't work when I make a triple quote. It's because it doesn't use single quotation marks, it uses this backtick. Yeah, I learned that yesterday. So that guy is that guy, and that guy is that guy.